3D printing is one of the most rewarding hobbies there is. However, it can also be a path to the dark side if you're not careful. This is a 3D printed Darth Vader helmet, and I'm going to show you step by step the honest reality of what it's like making something like this. The ups, the downs, the mistakes, and setbacks you may face. I have a lot of tips, tricks, and advice to give you in case you wanted to make one for yourself. So be sure to watch till the end if you want to see tips such as how to completely remove orange peel and achieve a mirror-like finish, as well as an extremely cheap and easy way to vacuum form lenses for your 3D prints. So without further ado, let's start at the beginning. Using the files provided by Dio3D, I printed the larger parts of the helmet across my FDM printers, while the smaller accessory parts were resin printed in order to maximize quality. Once all the parts were finished printing, I needed to workshop how everything was going to connect together, and it's here where I ran into my first issue. The neck piece was designed to snap into place by using these really small 3D printed pins, which were an absolute pain and in my opinion just a bad design altogether. So I experimented with a few different alternatives. First, I used some strips of elastic, which made it easy to put on the helmet, but not easy at all to take it off. So I settled on a combination of elastic and magnets instead. I created my own magnet slots in the helmet by heating the magnets first with a heat gun, then pressing them into the areas where the 3D printed pins were supposed to be. As for the dome, I used duct tape to temporarily hold the parts together, then used my soldering iron to weld along the connection points, fusing everything together permanently. One of the most important steps in a project like this is sanding down the layer lines and imperfections. I did unfortunately have some pretty nasty layer lines as well as a few minor layer shifts on some of the parts. Now, I've already talked in detail in previous videos about my process of sanding 3D prints, so if you want more information, there's a link in the description to a playlist where you can check out all of my previous builds if you would like to hear more. To be completely honest with you, I had a really hard time getting this helmet smooth. It was at this stage in the build where things started to fall apart, and I began doubting myself. Things started out fine at first. I sanded the helmet as much as I could, I used Bondo spot and glazing putty to fill the deeper imperfections, and sprayed a combination of high build primer as well as duplicolor filler primer over and over again to smooth everything out. Yet, despite my efforts, I was unable to hide one of the seams on the backside of the dome where I had fused the parts together. No matter how much filler product I used, the line was still visible and felt uneven. I was unsure whether it needed to be filled or sanded down. I tried sanding that section down even more. I even tried using a thick mixture of UV resin and baby powder to level the surface, all of which unfortunately led to the entire piece cracking along the seam while I was rinsing it off in the sink, preparing it for another coat of filler primer. At this point, I was already a week and a half, almost 2 weeks deep into the sanding process. A setback like this was gut-wrenching, knowing I needed to start over when I was so close to being done. I was angry and frustrated. It was those very emotions which ensured that the piece would no longer be salvageable. I'm only human after all. Despite feeling defeated, I knew I had a decision to make. Print the dome again exactly how I did before in multiple parts, which is the fastest option, but I risk running into the same issue once again. Or I print the entire dome in one piece on my Cobra Max, which takes significantly longer, 3.5 days to be exact, with the added assurance that I won't have to worry about any of the connection seams anymore. As hard as it was to wait an additional few days to print it in one piece, that's what I decided to do. Once the new dome was printed, I thought any further delays were behind me, but I couldn't have been any more wrong. It was at this moment where I got sick with the flu and was physically unable to work on this project for an entire week. In hindsight, maybe it was for the best. I was definitely burnt out and needed a break from the project for a little while. Once I recovered, I sanded the new dome smooth with no issues at all. In total, including delays and the time I was sick, it took me 27 days to prepare this helmet for painting. I want you to take a second and imagine what color Darth Vader's helmet is. If you're like me, you may be imagining an all-black helmet with a high-gloss finish. What if I were to tell you that Darth Vader's helmet isn't entirely black? Vader's helmet actually has asymmetrical metallic highlights, something I didn't even know until I started researching for this project. During the production of A New Hope, the original vision for Vader's helmet was an entirely black helmet. However, they realized that on camera, the helmet appeared washed out and flat, so the gunmetal highlights were added to help define the shape and features of the helmet, which made looking at the helmet more visually engaging. I recognize it may seem a little complicated as far as how you would achieve that kind of finish, but stick with me, I'll show you exactly how I was able to do it and what I used as a reference in order to mask off all the metallic areas. First things first, we need to apply the base coat on all the parts. I used two different types of black spray paint, a Rust-Oleum gloss black as well as a high performance enamel which was a flat black. I used the gloss black on the facial portion of the helmet as well as the smaller accessory pieces. The reason being is I figured the metallic gunmetal paint would better adhere to a glossy base coat rather than a flat colored base coat. As for the flat black, which was this high performance enamel paint, I really wasn't a fan of the results. After painting the dome and neck piece, there was a really strange aberration that appeared on the dome the following day. For whatever reason, I don't have any footage of it. Part of me was probably in such a deep panic, worrying that I may have to start over with a third dome this time, that getting footage didn't even occur to me. A palm-sized section of the dome had a bumpy texture that I've never seen or dealt with before. Luckily, I was able to wet sand and smooth it out. Instead of recoating it with the same paint, I instead went with a non-high performance enamel paint and just used a regular Rust-Oleum flat black. Now it's time to start masking off the areas that are going to be painted gunmetal. During my research, I came across a YouTube channel that makes screen-accurate Vader helmets. One of their videos provided reference images for how they mask off their helmets in order to paint the metal highlights. I'll leave a link in the description to their channel as well as the specific video in question. Once the masking tape was applied, I used a Duplicolor Toyota Magnetic Gray and applied 2 light coats. From there, it was time to carefully hand paint all of the small details. I loved getting to do this part because this is where the entire look and feel of the helmet really started to come together. With the entire helmet officially painted, the next thing to do is give it that high gloss finish. To do this, I'm using a 2K clear coat. Once again, if you'd like to see more information on this product, then feel free to check out some of my other previous builds, specifically my Stormtrooper helmet build where I talk about this clear pretty thoroughly. After applying 3 coats on all of the parts, I gave them each a full 24 hours to dry before handling. Now that the clear coat has dried, it's here where we may have a difference in opinion. At first glance, the dome may appear fine to you. Even looking at it on camera, I think most would say it looks good. It's shiny, it's glossy, it looks Darth Vader-like. Upon closer inspection, however, this piece has some pretty severe orange peel, more than I was comfortable with personally. There's a multitude of reasons as to why this happened. Cold weather is my number one guess. It's the middle of winter here on the East Coast, so the cold temperatures are not ideal. This clear coat operates best in temperatures 60 degrees or higher, so unfortunately, my only option is to use a space heater to heat up my shed where my paint booth is set up. Once I'm ready to paint, I remove the heater and hope and pray that the temperature stays warm enough throughout the duration of the clear coat process. Thankfully, this isn't the end of the world. There's a way to fix it and remove the orange peel entirely, and I'm going to show you how. In order to remove orange peel, we need to wet sand the entire helmet, then buff and polish the helmet the same way you would a car. For demonstration purposes, I'm only going to buff and polish one side of the helmet, that way you can clearly see in real time how much of a difference this extra step can make. All you need is a spray bottle with water and fine grit wet sandpaper. I started with 1000 grit and worked my way up to 5000 grit. The main thing to keep in mind is to be extremely careful not to apply too much pressure. You basically just want to keep the surface as wet as possible and let the sandpaper glide across the surface until you feel the roughness go away. Once the sandpaper can smoothly glide without any resistance, then you're good to go and move up to a finer grit. If you apply too much pressure, you could burn through the clear coat and into the base coat, which would be a major problem. Having several layers of clear coat is a good way to help with this. Anywhere from 4 to 6 layers of clear is pretty safe. Now that one side of the helmet has been fully wet sanded, it now looks absolutely horrible. So let's fix it. To do that, I'm going to be using a 6-inch dual action polisher and 4 different pads, all of which were picked up from my local Harbor Freight. I'll also be using Meguiar's compound and polish. Links for everything I'm using will be in the description. To make this as simple as possible, here's the exact order in which I did things. The 2 pads on the left were used to apply compound, while the 2 pads on the right were used to apply polish. I started with the white heavy cut pad and worked my way up from left to right. We're starting with compound first because it's the most abrasive product. It's going to do a better job at removing scratches that may have been caused during wet sanding, as well as removing any other imperfections that may exist. You'll notice too that the compound is immediately going to bring back the color, as well as a little bit of the shine that was once there before. Not to worry though, because the polish is what's going to really bring back that gloss and clarity that we're looking for. My biggest concern during this process was damaging the paint. Since I was using a 6-inch polisher, I was covering a lot of surface area, but I needed to make sure I kept the pad moving at all times as to not generate heat in one spot, which could have burnt through the paint. It took me a total of 2 hours to wet sand, buff, and polish just one side of the helmet, and what you're seeing now is the end result. I am by no means an expert on polishing, I just know what I know, and I think the results speak for themselves. As you can see, the difference between the 2 sides is night and day. I think it's a good thing to keep in mind that some mistakes and setbacks, such as clear coating in cold weather resulting in orange peel, don't need to define your project. Life isn't always going to provide you with the best conditions to do the things you want to do, but that shouldn't stop you from trying, because you never know. There could be an alternative or a workaround. It's just a matter of finding it. With the helmet painted, clear coated, and now polished, one of the last things we need to do is make the lenses. As promised, I'm going to show you an extremely cheap and easy way to vacuum form lenses for not just this helmet, but any other sized ones as well. As it stands right now, vacuum forming at a hobby level is extremely expensive, with machines ranging anywhere from $600 all the way up to several thousands of dollars, with the only real alternative being to make one yourself. But not everyone has the tools, ability, or know-how to do that themselves. Enter the solution. This is an all-in-one 5-inch by 5-inch vacuum forming machine that I found on Amazon for only $118. That was primarily made to be used by dentists to make retainers and mouth guards. It has a built-in heater as well as vacuum, so aside from plastic, nothing else is needed to get started with vacuum forming. I know what you may be thinking. Yes, this machine is pretty small, but don't underestimate what it's able to do. The lenses for this Vader helmet fit perfectly into the machine. I was even experimenting with making lenses for a Spider-Man mask, which also fit with no problem. No, you can't make visors or large items, obviously, but this machine has been a really great way for me to get my foot in the door and learn the basics. That way, if I want to make my own bigger machine later on, it won't be that much of a headache. To be completely honest with you, again, my experience learning how to vacuum form was an absolute disaster. If you thought I was struggling during the sanding process, my god, you have seen nothing yet. An alternative title for this video could have been, I learned vacuum forming the hard way so you don't have to. I made countless costly mistakes, which is why I'm going to show you exactly what not to do should you choose to get this set up for yourself. So we have the machine. How do we actually use it to make Darth Vader's lenses, though? To do that, we need to make a buck/mold of the lenses. DO3D included a printable version of the lenses, which is what we're going to use. To do this, I oriented them to where the front side was facing upward. Then in Orca Slicer, I generated a cylinder and attached it to the center of the lens. That way they could be printed ever so slightly raised. I then generated tree supports all underneath the model to support it. Once printed, I kept all the support material intact and sanded the surface smooth, same as I did before on the helmet. My first mistake was not using the right type of plastic. When I purchased the machine, Amazon recommended the plastic sheets that are meant to be used with the machine that are pre-cut to 5" by 5". The material, however, was this really squishy, flexible plastic that could be vacuum formed but isn't good material for lenses. My first attempt at using the machine was a disaster. Because the heat element and the vacuum are built in, I placed the lens buck onto the machine and left it there during the 2 to 3 minutes that the plastic sheet was being heated up, not realizing that the buck was also being heated and warped. Since I was using sprayable filler primer as well to smooth the lens buck, that too was being heated, which was a disaster. When I pulled the plastic sheet onto the mold, the entire surface bubbled and all of the filler primer was pulled off the model and onto the plastic. I experimented with a few different types of plastic. After doing research, I found that PETG was the way to go. Unfortunately, there's nowhere nearby that sells this type of plastic, so it needed to be ordered. Luckily, I came across this seller on Etsy that sells sheets of PETG at various thicknesses, and you can choose which dimensions you want as well. I ordered both the 0.04 and 0.03 inch thick sheets, just in case. The only downside is that it took me a week to receive them, but that's my own fault for not being prepared, further delaying this project even more. The main issue I was having was with the molds themselves. Because they were printed in PLA and needed to be sanded, I kept having to re-sand and smooth them after vacuum forming. I eventually started coating them with UV resin, which did a much better job resisting the heat. I also experimented with heat-resistant spray paint, which did help a little bit, but was still not strong enough to fully protect the mold and the paint from heat. In the future, if I were to do this again, I would modify the design of the lens buck and figure out a way to resin print them entirely. So we've covered what not to do. Now I'm going to walk you through step by step on what to do in order to successfully vacuum form the lenses. Make sure that the sheet of PETG is free of any hair or dust. Heat the plastic until it starts to droop. If it droops too much, it could potentially start to rip and tear. If it doesn't droop enough, then it won't properly form to your mold. It took a little trial and error, unfortunately, but there's plenty of wiggle room in between. I wouldn't stress on that part too much. Once the plastic droops to your desired amount, turn off the heater, then place the lens buck onto the machine, drop the plastic, and turn on the vacuum to suck out the air, forming it to your mold. Once you remove your vacuum-formed mold, you can use a pair of scissors to cut out the lens. Now that we have our vacuum-formed lenses, we need to make them dark. To do that, we're going to dye them using iDye Poly. I boiled the dye in a pot of water and stirred it well. Before we can add the lenses, the water needs to cool down to about 150 degrees Fahrenheit. I was dyeing in a temperature range of 135 to 150. Anything higher runs the risk of warping the plastic. My major mistake when doing this was dropping the lenses into the pot. Because the lenses were so small, they immediately sank to the bottom and were resting with chunks of unstirred dye, which resulted in the lenses being completely opaque with chunks of dye fused to the surface. The best way to dye them, I found, is to wear gloves and by hand manually dunk them into the dye for about 10 to 15 seconds at a time. Then immediately soak them in a pot of cold water to shock them. repeating this process over and over until the darkness is to your liking. The thing to keep in mind when determining whether or not they're dark enough is to hold them against a dark object. When held against light, they have a purple, transparent-like appearance, but when held against something dark, they look solid black and non-transparent. Once they were dark enough, I let them air dry before cleaning them off with plastics cleaner, which is meant for clear plastic. Fear is a path to the dark side. Fear, self-doubt, and a whole bunch of negative emotions clouded this project from start to finish. I've held myself back from making a Darth Vader helmet for a long time now, and after a month and a half of work, I finally have one of my own. Getting here wasn't easy. You saw firsthand the mistakes and setbacks that I experienced along the way. But those don't have to be your mistakes. Please learn from mine and apply those lessons to your own builds in the future. I hope you enjoyed getting to see an inside look on how this Darth Vader helmet was made, and how I almost turned to the dark side in the process.